Okay, so what you see here is a four-dimensional simulation of the game of life. And what I have done here is separate the different simulation spaces with different colors and different movement. So what you can actually see here is a four-dimensional object of the game of life, and you can separate the different simulation spaces because they have different movement and a different color space. So for example, this weird form here is inhabiting one of these simulation spaces. This rectangle in the center is inhabiting one of these simulation spaces. And for this simulation in total, there are 6 simulation spaces where the simulation is happening. And the game of life simulation, what it is about is there are single cells, single dots here in the simulation. And for each of the cycle, which are these transitions here, for each cell the simulation counts how many neighbors do they have. So neighbors would mean different dots in the simulation, which are next to each other. And if the neighbor count for a cell is correct, let's say number 3, then the dot in the simulation is going to get born or survive. And I can choose what are the rules of the simulation. So for example, now here, the first prime numbers are the rules of this simulation. And if a neighbor count is one of these prime numbers, then a cell is going to get born in the simulation. And the end result is what you can see before your eyes. But earlier I said that I have separated this simulation to different simulation spaces. But if you ask a single cell, a single dot in the simulation, they know nothing about simulation spaces because they only have neighbors. It's a trick to separate these visually so that we can see and understand them better. In the geometry, there is no real separation of the simulation spaces. They are all the one and same simulation space. But I have separated these so that we can understand and see what's going on in the simulation. And this simulation supports up to 6-dimensional game of life simulations. And for those we can have, for example, 100 simulation spaces where the simulation is separated. And the higher the dimensional count of the simulation and the size of these dimensions, the higher the simulation space count I'm separating the simulation to. Because if we try to squeeze all of the information in the simulation to one simulation space, it's going to get completely crowded and we can see nothing there. But when we do this visual trick of separation, we can see these hyper objects of multiple dimensions and appreciate the beauty which lies within. And I have made this simulation for iOS, Android and Windows, and you can get it for your own device. I will put the download links into the description so you can easily get it for your own testing. This is all for now, and bye.